Welcome to this comprehensive video tutorial on 3D face recognition techniques. In today's session, we will dive deep into the fascinating world of facial recognition, turning our attention specifically to 3D modeling techniques. Let's get started by understanding the basic concept of face recognition. Traditionally, facial recognition systems relied on 2D images. With the advancement of technology, we now have the capability to utilize 3D models for more accurate recognition. But why 3D and not 2D? That's a great question. 3D face recognition techniques leverage depth information that can provide a more robust identification process, especially under varying lighting conditions and facial expressions. In this video, we will cover the following topics: understanding 3D face recognition, setting up our development environment, exploring libraries, processing 3D face data, and finally implementing a face recognition model. First, let's talk about what we need to set up our development environment effectively. For this tutorial, we'll be using Python as our primary programming language, along with some powerful libraries for 3D processing. You will need the following components to start. 1. Python 3.x installed on your machine. 2. OpenCV for image processing. 3. NumPy for numerical operations. 4. Matplotlib for visualization. 5. Glib or a similar library for machine learning. Once you've installed all the libraries, let's delve into how a basic 3D model can be constructed from a set of images. This typically involves capturing multiple images of a face from different angles or using a 3D scanner. To illustrate, let's write a function to load images and create a basic 3D point cloud representation. We'll use the OpenCV library for image handling. Here's what the function will look like. Now that we have our function to load images, let's see how we can generate a point cloud. A point cloud consists of points in 3D space, representing the outer surface of an object. We're now ready to generate our 3D face model. In a real-world application, you would use depth maps or stereo vision techniques provided by your camera setup to retrieve accurate spatial coordinates. Next, let's discuss how to use Glib for face detection and recognition. Glib provides a powerful toolkit for machine learning and is particularly well-suited for facial landmark detection, which is crucial for aligning faces in 3D. The next step is to load an image and detect facial landmarks. This will help us map the coordinates of the face onto the 3D point cloud we previously created. Let's integrate our point cloud data with the facial landmarks detected. This will allow us to align the 2D features of the face with our 3D model. Now that we can align our faces with landmarks, let's move on to the actual recognition. The key here is feature extraction. We will utilize computed descriptors from Glib for each face. Now we will architect our model for face recognition based on the extracted descriptors. We can use a simple Euclidean distance method to compare face descriptors for recognition. To test our implementation, we will create a main function that orchestrates the entire process from loading images, detecting landmarks, generating point clouds, extracting descriptors, and finally recognizing faces. Now we've implemented a simple yet comprehensive 3D face recognition technique. You can experiment more with various models and datasets to enhance your recognition capabilities and increase accuracy. Be sure to tune the parameters as necessary to find what works best for your specific use case. For our next video, we're going to delve deeper into techniques such as deep learning for 3D face recognition using neural networks, which can provide even more sophisticated methods and better results. So make sure to stay tuned. Thank you for watching. If you found this tutorial helpful, please give us a thumbs up and subscribe for more tutorials on advanced topics in computer vision and artificial intelligence.